Hello.
Hey, Excuse me. Hey, Sandy. Hey, Greg. How are things, Sandy? I feel like I haven't talked to you in a while.
Good morning.
Yeah, it's been ages.
I know.
Yeah.
Yeah, busy, busy.
Yes. Agreed.
Hi. Hello, everyone.
Hey,
Hi,
Colin.
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 Happy to see you, Greg.
Hey, Colin. How's it going? Good to see you, Sam.
Yeah, no,
Hi,
very happy
Hello.
to see you.
Everyone.
Hey, Justice.
Good day, everybody.
You always have the nicest view of anyone in any meeting that I'm on, Justice. Consistently, so you should be proud. Yeah. Twist the knife.
Yeah. Hey, Fully.
Hey, Greg, how's it going?
Hey, Justice. Yeah, some people are in Cape Town. So, um,
You're muted, Justice. Oh, he's on his way here as well, apparently. So we just found out that I won't be alone in Cape Town.
uh, where are you at?
We're on the peninsula, so around Fishhook, and Simonstown.
Gotcha. Oh, you're actually a ways away then. I like that area. That's where you usually see well, somewhere in Simontown.
It's generally a little bit more quiet than the city. It's very much outside of the city at the moment,
Oh,
but
yeah.
the the property prices here have probably tripled or quadrupled in the last 5 years. It has been crazy.
When I know it. The last place I stayed was kind of cliffside. It was the Airbnb, the only one that had all up. So it just hung out there.
This is a lovely area.
Uh, saw the big ones and all that jazz. Yeah, the throws get kind of intense there, Ben, but it's a shallow fake bay, if you will. That whole area. Lots of sharks
And
as
it's a
well.
lovely area.
Yeah.
Not anymore. We had a pair of orcas invade this bay and basically killed all the sharks.
Oh, really?
So they, yeah, they used to have a very sort of as a tourist destination, a lot of shark cage diving, especially with the great whites. But the pair of orcas came in here and killed all the great whites. There are no great whites left in False Bay at the moment.
Wow.
Apparently, the orcas just killed them and ate the liver and then left the rest. It's quite savage.
That's weird, huh?
Okay. Yeah, no, it's crazy. National Geographic out here all the time. Shall we get started? I don't think we're waiting for anybody else. Everybody else who is going to be here is going to be here. So thank you very much, everybody. This is probably also going to be our last technical steering committee meeting for the year. And we will reconvene these in January. I think probably not the first scheduled session in January, Ben and Renew, but maybe the next one, so the last one for the month. And then we'll pick it up again from there. I think also just from a forward-looking agenda perspective, Ben, if you could maybe help us get the year next year kick-started with a review of the community OKRs that we've agreed as part of our upcoming grant, because I think that would also set the scene for how we expect this forum to develop in the coming year, especially as we transition into a more of a community-led project.
Yeah, that sounds like a great idea.
Yeah, thank you. All right, so just to kick us off, this is our Linux antitrust policy. You can read through this. If you have any queries about antitrust, if you are a Linux employee, you can contact the Linux lawyers. If you are not a Linux Foundation employee, then you hopefully have lawyers of your own that you can contact about antitrust matters. And then just for our agenda today. So what I wanted to do today, and again, because this is going to be the final session of the year, we don't necessarily want to do anything new, but I do want to lay the foundation for probably what is going to be our most important set of features enhancements for 2026. And that is full exploration of AI and machine learning in Tazama. And I want to be able to show you what we can expect from AI and machine learning for Tazama in 2026, at least as the foundation. Some of you may already be aware that there is a large variety of features coming up for Tazama out of the COMESA implementation specifically. And some of those features will also be to implement some AI and machine learning functionality. So I'll show you what is coming up so that we know where we are starting from. And then we'll see maybe just as sort of a foundation or a roadmap going forward, what we would like to add and where we may require your assistance from a technical steering committee and also wider community perspective. So starting off here, this diagram, I think everybody has seen multiple times now. So this is our COMESA implementation, piggybacking off the Moduloop implementation that's currently underway and about to be rolled out. The implementation phase of this project is likely to start next year, and we are busy closing off the features development phase now. So out of those features development, you will be able to expect this entire ecosystem. Now, I've called out specifically some of the components here where we are planning to put AI and machine learning into it, and that is the initial feature development to implement this functionality. And then also this functionality will be implemented for COMESA and then battle tested in the COMESA environment. So these are going to be operational AI features for Tazama around Q1 of next year. And I'm going to be going through these in just a little bit of detail so that we can see what the foundation is, and then we'll talk beyond that. So immediately, we'd already done and reported here at the Technical Steering Committee meeting, an update to our data pipeline to add an independent variable to all of the rule results. So the independent variable, where we had previously delivered a bucket result out of a rule processor, we are now delivering the value that goes into that bucket to determine the bucket. So it's essentially the raw data that we used to determine the rule result. And that raw data is a lot more valuable in machine learning modeling. So we wanted to have that data being reported out of the system. And then we want to be able to use that value to help us calibrate all of these models. So the independent variable update already went live, and that is part of Tazama 3.0.0 now. And I'll show you a little bit about what we had done with that, but we did a sort of a POC on using that feature to do some AI and machine learning modeling for a linear regression model that can then be used to predict fraud as long as you have the labeled data in order to train that model. And that's something that you'll be able to do already. And we've already spoken to a couple of people in the community about that. So there are some people who are already sort of evaluating it, investigating it, and seeing how you could operationalize it. But we are also going to be operationalizing that inside the COMESA project. And then in addition to that, we delivered automated alert triage. So that is functionality that has already been developed, but it is a component of the upcoming case management system suite. So that component is not yet operationalized and not yet published. It will only be published once the overall case management system itself is complete, because it relies on the case management system workflows and data to be able to run and operate. But once case and investigation management is implemented, it will come with an automated alert triage module. And then in addition to that, these are all activities that are currently underway and expected to be delivered in Q1 2026, and we hope as early as February. It is the AI machine learning for model refinement, which I just mentioned we'd POC'd, and that was particularly to deliver a linear regression model, which is the easiest transition for the current typology processor. And then we also want to be able to implement artificial intelligence and machine learning for anomaly detection that will then help us to discover rules, to extend the rule ecosystem for a particular client based on their specific data and investigation outcomes. And then also typology discovery. How can a number of different rules be composed into new typologies that can then help detect new and emerging behaviors inside a particular client's ecosystem? So these are all things that are coming up for 2026, and those will be delivered out of the COMISA project. So I wanted to maybe just quickly give you an overview of how Tazama detection works at the moment, especially with the rule space that we have. So you may recall, and I think many of you have seen this diagram already, a rule processor will deliver a result, and those results are formulated as one of a number of mutually exclusive outcomes. So you can have bucket 1, bucket 2, up to bucket n. There could be some exit conditions that says that we couldn't determine a meaningful result. There could also, worst case scenario, be an error outcome. So all of these different outcomes are possible out of every rule processor, and they then send these results into the typology processor. In the typology processor, those outcomes are each explicitly weighted with a specific value. And typically how we have been doing this on sort of a gross basis is to say that a low bucket is a small value, and a medium bucket is a medium value, and a high bucket is a high value. And when we say you need small, medium, and high, we typically mean it's 100 or a 200 or a 400 value, so that it kind of escalates and slightly logarithmically. So, and I call that a gross method because we didn't have at the time any real data that we could use to train these models. And when we initially did try and train a model for this, we discovered that it is a very complicated process. And it took us a little bit of time to get our heads around how we would approach this, because initially we picked the bucketing system to make it easier for people to manually fine-tune these models. And then when we tried it ourselves, we realized that even with the bucketing system, manual fine-tuning is probably a bridge too far. It's far too complex. There are far too many moving parts, far too many variables. It's almost impossible to be able to train or fine-tune even one typology, let alone all of the 33 typologies that we had in the system. But you get these values that are now assigned, and these are all defined in a typology configuration file. And every typology has one of these. So every typology is effectively a model that weights all of the rule results for that particular typology. And then inside the topology processor, there's a caching mechanism to collect and evaluate these as they arrive. And then at the end, this is effectively our typology score. And we evaluate that score against a threshold. In our calibration efforts, the threshold was probably the easiest thing to tweak. So we could pick a threshold that up to a certain point, if we kept on increasing it, it would get better. And then after a point, it would get worse. So that point where there's almost a watershed, that was what we considered to be our optimal value. But we couldn't really tweak anything else. So then we implemented the independent variable. So with the independent variable now as a result, what we are able to do here is the rule processors are effectively feature generators. So every rule processor by itself is considered an AI or machine learning feature that delivers a value. And they still will remain rule processors because every one of these rule processors does a lot of work by itself behind the scenes. You can't just evaluate a transaction based on the transaction that you're looking at. You essentially have to evaluate a transaction against its entire history, the history of the participants, and any other additional information that you think might be relevant in a particular rule. That rule does all of that work. So they are all little, almost data collection engines by themselves, or data evaluation engines by themselves. And they generate what we call in AI and machine learning a feature. Right? So we have now, with the independent variable, we can call our rule processors feature generators, AI and machine learning feature generators. And now what that means for us is we can directly train a linear regression model on these features. So if we have a data set and that data set comes with labeled outcomes, then we can say what kind of linear regression formula, and particularly a multidimensional linear regression formula, can we train that will optimize the prediction of fraud. And we've done that in a POC, and I'll talk a little bit more about that in a future slide. But we had actually done a POC, and we were able to achieve model accuracy for fraud detection at about 93, 94%, which was very high, with false positives at just over 5%, where the industry norm is somewhere between 5 and 10%. So based on the features that we already had, that we didn't have to tweak at all, and just applying a linear regression modeling approach, we were able to achieve a fairly high level of accuracy. Obviously, this approach requires data to be able to train and test the model properly. There is a change that we need to make here. So the typology processor itself, if you look at this one here, is a very simple formula where it just basically adds up the weighted values, right? What we need to do is the typology processor needs to be adapted slightly because it needs to carry a value for noise and also a value for error in the multidimensional linear regression formula, both here and here. And then this part in the middle is essentially the same thing as what the typology processor is doing now. It takes the independent variable here and multiplies it by this feature coefficient here, and then delivers the value that goes into the sum. So the bulk of the behavior here is still very much the same as the existing typology processor. We just need to enhance the typology processor slightly to also be able to carry these values and add that to the modeling outcome for a more accurate result. Right. So that is, Tazama is effectively, with the independent variable, I would call it AI ready or machine learning ready. And you can already train a AI machine learning model for linear regression out of data and then apply that inside Tazama. So this is the POC that we created. We did this in Jupyter Lab using Python. So ultimately, this would then load a data set, which we turned out it was a CSV. And that CSV was basically a report out of all of the evaluation results for a particular typology. So we took our scam typology, and then we delivered a vector out of that scam typology for every transaction. And then out of that, there's some routines for the exploratory data analysis that you typically start with to help you identify which are your most prominent features, where you may have things like multicollinearity in the data, which features are redundant, and so on. And then it did a linear regression model for fraud prediction out of that, which initially showed some very, very promising results. So immediately, right off the bat, with a vanilla application of this model, as I mentioned, we were able to achieve 93, 94% accuracy with 5.5% false positives. And then there's also routines in here to evaluate the model performance itself. And this is available, so if anybody wants to have a look at it, I'll be happy to share it. I think the Cyber team already also have a copy of this, so they have been exploring it. Our system integrator in Mongolia also have a copy of the routine, so they are also exploring it there. So we're quite happy to share this if you want to mess around with it. Unfortunately, at the moment, when we did this POC, we based it on Tazama 2.2.0, which still used a RangoDB. We do need to refactor this model now to accommodate our Postgres migration. That shouldn't be a lot of work, but that is something that I'm planning to do in January, and then we'll have a working model again that runs on Tazama 3.0 as well. And then out of this model, you get a whole bunch of sort of metrics and graphs and things that you can look at. So essentially, it takes the vector, and then through our Jupyter notebook with Python, you get a whole bunch of values here, and I'm not too sure if you can actually see it on the screen, but it gives you what are called coefficients. So if you look at this value over here, that is the value that goes into the configuration as the multiplier, right? So you can use this model to fine tune and calibrate this particular typology in the system. And all you need to do is you update those values where we previously had 100, 200, and 400 in the configuration file. You will literally now just put in one value that multiplies with, where am I now? With the independent variable result. So you'll see all of those rule results over here. You just multiply it with the coefficient that is given to you by the model itself. Okay. So this process is a POC, and this will be operationalized and implemented in Tazama for Kumesa as well. So again, we're expecting to see that in Q1 2026. Right. So this is the alert triage module. I just wanted to quickly briefly show you what this does and where it lives. So it is a component inside the case management system. When we initially designed it or specified it, we thought it might be a component ahead of the case management system. But then we realized it would actually make more sense for the case management system to automatically create the case on the alert in any event regardless, and only then route it for triage. So that the triage module can then interact with the case inside the case management system and then automatically close it if it can predict what the investigation outcome is going to be. So the model behind this has already been completed and developed, and the component is available inside the case management system. What it will then do is it will receive a Tazama case, and it will then triage that case with a specified or configurable level of confidence. So either above 95%, it will agree that the outcome that it is predicting is very high in confidence. If it doesn't achieve a confidence level of 95%, it will send that case through to the case management for investigation anyway. And you can tweak the value here to match almost the capacity that you have in your investigation team. The purpose of the alert triage module is completely to spare your investigation team's capacity as much as you can. You want to be able to predict low priority case outcomes or high volumes of case outcomes within a particular range so that you can automatically close them and your investigators don't have to go through an investigation, because your investigation teams are typically already overworked and overrun with alerts. So the system will then eventually say, okay, is this a true positive result predicted? Is a false positive result predicted? If there's money laundering involved, we need to investigate it anyway, because that is typically a regulatory requirement. And then finally here is if it is fraud only, and we say that Tazama had taken action, right? If Tazama had blocked it, then Tazama had done what it was supposed to. And if we agreed with that, we will auto close it to say that we confirm that the alert is correct, right? But if the transaction already happened, you're probably going to want to investigate that case anyway, because somebody lost money somewhere. And this is probably an instance where law enforcement has to be involved. So we can't ignore that case, and we can't ignore a case or auto close a case where fraud had actually occurred. So if we can predict that the investigation outcome will agree that fraud had confirmed and the transaction had actually happened, then we will investigate that case anyway. So for money laundering and for situations where the transaction had occurred, that case is investigated. And the alert triage module is designed to be trained on investigation data and investigation outcomes over time, and manage these alerts and automatically close these cases, and then continuously be updated and refined as new data is applied and investigations are concluded. Right, and then this is the final one that we are looking at. So you may think that this slide is slightly light on detail. You are correct. This is still a process that we are investigating. There's still a little bit of research and development required here before we can implement a model. And partly there is also a dependency on the delivery of the business intelligence, analytics, and reporting stack, because this work will be done on data that is collected and contained in the BIAR during investigations and alerts. So we need to be able to create that foundation first before we can start exploring what anomaly detection looks like in that environment. So how this would fundamentally work in principle is you will take Tazama alert data that is delivered to the data lakehouse. And then also in particular here of importance is post-event fraud reports. Because what we are looking for is the anomalies in emerging patterns of behavior, and typically that would relate to fraud detections that we missed. And that would be fraud that people had then reported after the fact. So those are critically important, and when somebody reports the fraud, that would then also go for an investigation, and the investigation would either confirm or refute the fraud report. And that labeled data then goes into the anomaly detection engine. And then what we expect to get out of that anomaly detection engine is a list of new proposed features that we can then turn into rule processors, and also typologies that says a specific collection of features will give us better detection on specific types or instances of fraud. And then that is what the anomaly detection will also be able to give us. And again, this is going to be part of the COMESA implementation. Right. So now, any questions up to this point about the things that we are proposing to deliver by Q1 next year? Okay, thank you very much. Hopefully I haven't talked everybody to sleep yet. Okay, moving on. Right,
Hey, Justice, sorry I was
what
on
we
mute.
want, yeah. Great.
I've got a quick question. Could you explain explainability and what we need and how it's different from what the default is on AI right now? We have to be able to
Okay.
explain for an investigation what's going on.
So our explainability is essentially this model here. So what a lot of other AI and machine learning models have is this entire process is a black box. You send data into it and you get a prediction out of it. And then what typically happens is you have to take that prediction and the process that you followed, and then you have to walk it back to try and identify or define or declare how you came to that result. And there are models that does that. The one that Sandy recently encountered is called Lime. Sandy, there was another one as well. I can't remember what the other the acronym was. Can you remember?
SHAP, I think. SHAP.
Right. Yeah. Which, you know, to South Africans means something completely different, but yes, SHAP, right? So there's a SHAP model, and then there's the Lime model. Those are designed to help you identify or explain your model's behavior after the fact. What we have done, and probably, well, not probably, but this was deliberately a decision on our part right up front when we built Tazama, is we wanted explainability built in. So the third method that you would use for explainable models is called features. I've forgotten the word, Sandy, please help. Feature transparency or something, feature identification or feature cataloging.
Importance.
Yes, thank you, feature importance, right? So with feature importance, we have that already built in because we separate the features from the calculation process up front. So all of our features for any given alert are already defined and cataloged as separate components of the result. So when you get the prediction, you already know all of the things that went into that prediction out of our modeling and our alert. So from a basic explainability perspective, I think Tazama has that covered. If we have to explore slightly more black box approaches, then we would have to consider which of the other two, Lime or SHAP, or if we can make feature importance work, what other methods we would need. But for the moment, based on our current model architecture, I think we're okay.
Well, thank you.
Josh, question.
Yeah, Justice, I have one question. I know, like here in the US, AI regulations are starting to actually come at the federal level, but in other countries, we don't have any. My question would be, would this be proof of liability in the AI model once those in the future come around, to maybe address that? Because you can actually have the
I
explainability in the model.
I am
Hey,
not sure because I know that people have been talking about AI regulations, especially also here in Africa at the African Union level. I am not sure at what point those things are going to be executed or implemented. I think a lot of the AI regulations that I've seen deals with the responsible handling of data,
yeah.
making sure that your models aren't biased and disenfranchising people unnecessarily and those kind of things. So I'm not sure if the question of liability itself is being addressed. What would the liability question look like? I mean, what is your experience of it where you
It
are?
would, to me, that would be like understanding trust, but verify that your AI is operating from the correct, like this model would explain where the actual answer came from. So the prediction that you're looking at. And that would answer the fact of trust, but verify in the liability scheme.
So in theory, there's the burden of some of the proof lies with the investigation teams, right? So if the system says that I have detected fraud, somebody needs to go and investigate it. We slightly muddy the water there, I guess, with a alert triage module that then compounds the AI result with another AI result, and then no human gets to look at some of these alerts.
Exactly.
Some of those alerts will still be challenged by somebody. So in our workflows, we do offer opportunities for things to be reviewed or reopened. Everything is also auditable so that an external auditor can routinely review the results from both the models and the investigation outcomes. So we provide some of the tools for that, but we have not necessarily considered it from a liability perspective. That's something that we can certainly also look at.
And to be honest, nobody really has, Josh. So they're working on that right now. But as Justice said, they've mostly done ethics first. So it's the data right, the bias, etc.
Yeah.
So we're not getting the easiest things out of the way, if you will.
Yeah, I
Um,
always ask the question. It's one of the harder ones.
I don't expect this to come for probably at least 2 or 3 years. But the point I was trying to make here is we have to have explainability to everything that we do. We currently have all of that, right? If you look at a lot of other systems, you literally said something more than fraud or not fraud.
Exactly. That's what my point was, that we have the explainability. So maybe it will address that once they start looking at that, and we won't have to worry about it as much. Is what my point was to that. Hopefully.
Yeah, kind of looking at, if you look at it from the topology level, the rule doesn't change. The work that Justin did on figuring out, he's going to talk about, I actually don't know if you're going to talk about more than linear regression. Um, we can prove the rule works and things like that. We already have an AI for that. So why not let the rule be a rule? We already have anomaly detection, so I don't leave that to be, in there, and just focus on the topology, making sure that it's right. Um, so anyway, we'll see where this goes, but we have to be able to, at the end of this, which I know you know, we have a JSON file with all of the um, explainability necessary to actually run an investigation. We're going to have to do the same thing with AI, and we don't have that all figured out yet.
No, for sure.
All right, I'll shut up now. I'm trying to stay out of the way.
No problem. These are great questions. Thank you very much. Okay, so on my final slide here, so we have a wish list, right? There are a few things that we as a team have identified that would also greatly enhance Tazama's capabilities and add AI and machine learning in a way that supports Tazama's vision and goals as well. We don't want to just add AI things willy-nilly, but we have gone through our pipeline and there are a number of opportunities here where we think we can add AI that will really improve and add value to the product. So I'm quickly just going to walk through these and review them. One of the challenges that we have is in most of our clients in our target market, and in particular at the level of switches or clearinghouses or central banks, is none of these organizations have ever done transaction monitoring at this level. The capability requirement for the detection of fraud through through transaction monitoring hasn't existed yet in a lot of places. It's very much an emerging regulatory space. So a lot of these entities have not been doing this work. And because they haven't been doing this work in the past, they have no history to speak of. There's no labeled data in any of these environments. And some of these operators are actually quite small. So, if you are only handling 1 to 2 transactions a second, then it takes quite a long time for you to accumulate sufficient data, right? And I mean a second, I actually mean per day, because some of these are even smaller than that, right? So it takes a really long time for you to accumulate sufficient data for you to be able to effectively train a model. Models are very hungry. The more data you can give them, the better labeled your data is that you can give them, the better the model outcomes are going to be. So we would like to explore AI and machine learning strategies here for low data environments or data scarcity environments or data sparsity environments. And then you saw the modeling for the linear regression. So it is a straightforward port into the typology processor at the moment, and we would want to rebuild that typology processor to be able to handle linear regression inputs. And that transition is a very, very small change for us. What would be great is if we can handle or create a typology processor that can do decision tree modeling based on the same rule processor outputs, or even random forest modeling, again, based on the same rule processor outputs, but putting that information together in a slightly better way. And the reason for that is we've done the decision tree modeling and we've done the random forest modeling. The accuracy of decision trees is greater than the regular the regular linear regression. I think that put us up to 97%, and false positives went down to just over 1%, which was incredible. I don't think I've ever seen that anywhere else. And then we did the random forest modeling, and random forest took our accuracy up to 99%, which was fantastic, which means 99 out of every 100 fraud alerts was accurately identified by the system. And then on top of that, it delivered only 11 false positives. So that was 0.01% false positives, which was very, very low. So it would be useful, I think, to also have typology processors in the system that is capable of doing decision tree modeling and random forest modeling. And then we want to be able to look at what other kinds of models are there. Linear regression, decision trees, and random forests have been around for quite some time already. The field of data science and machine learning and AI is evolving constantly. So what is new that would be even better? And then what we also want to be able to do, and this one I think is a big one for us, out of all of these, probably the highest priority here is we want to be able to implement an LLM AI assistant for fraud investigations. And this would facilitate or support the fraud investigator through the entire investigation process, almost constantly looking over their shoulder, looking at the data and the screens that they are looking at the context of a particular investigation against the background of all of the visualizations and data analytics that is available, and then assisting the investigator in making the best possible investigation outcome for a alert, and then also helping the investigator put the report together. That one is, we think, would add enormous value, especially in our constituency, because we expect that when we start implementing this system, the largest problem people are going to have is how do they staff investigation teams that they've never had to staff before? How do they train teams? How can they minimize the burden and the cognitive overload on these teams? So an LLM-based AI assistant for fraud investigations would be almost essential as a next step for Tazama. So we definitely want to explore that. And then there's a whole raft of these. So any manual or system process in the system could be improved through automation. Right? And at the moment, agentic AI is probably one of your quickest ways to ramp up automation of tasks, ramp up automation of data collection, ramp up and the way that it then goes and assists the system and the operator in performing a wide variety of tasks. So agentic support for automation of manual and system tasks, agentic support for data analytics. So if you are developing reports, if you are developing data visualizations, if you are using the Jupyter Lab environment, there should be some sort of over-the-shoulder support or connected AI that helps you with that particular activity. What we want to be able to do in our environment is sort of just lower the bar a little bit for the amount of skill required to drive the system. At the moment, the way that it looks like is if we just implement the system the way it is now, every operator out there is going to have to employ a team of data scientists to maintain the data space around the system. We want to minimize the load and the demand for highly skilled, highly expensive resources. And the best way for us to do that at the moment is to automate a number of these tasks through AI and machine learning. Also want to be able to keep track of all of our models. So the model that you saw and that I showcased now was a POC that we did on a single typology. In our current model architecture, every typology is a model. Right? So every individual model needs to be individually calibrated. The calibration needs to be individually monitored and reported. The more transactions you have, the more different kinds of evaluation models you're going to have for each of those transactions, and the more different models and typologies you are going to have in the system at the end of the day. So to manage that proliferation of models, you definitely want some sort of automated environment where these models will report on their own performance, track their own performance, their confusion matrices, and give you feedback on where a particular model is losing effectiveness. And then also, there's an opportunity here for an agent to perform the rudimentary model maintenance. So if a human can review the features impact, can review the results of a particular modeling approach, the evaluation of, for example, the linear regression, then an agent should be able to look at the same metrics and then also be able to come to the same conclusion and give some sort of insight into how a model can be improved. And that is something that we see in the beginning, at least, would have a human in the loop. But as this improves and becomes more effective and more reliable with fewer hallucinations, we would be able to automate this process entirely. And maybe just because I mentioned hallucinations in particular, there was a recent study on AI and machine learning that said that most organizations that are using AI, 61% of them are concerned about the hallucination of AI, where the results cannot be trusted. Everybody wants to be able to rely on their AIs, but there is enough noise about hallucination to discourage people from trusting them entirely. So we need to make provision for human in the loop. But one day, hopefully, these models will be able to carry on by themselves. And then the final step here is we also would like to create some sort of AI machine learning based synthetic data generation utility. Or at least, take our actual data and through some sort of privacy preserving approach, create synthetic data from the actual data that can then be used in a simulation sandbox for the same client to help train their models or to validate their model configurations or whatever the case may be. So these are sort of the areas where we think AI added to Tazama would be useful. I don't know, maybe take a quick straw poll. Is like anybody have anything that they expected to see in a wish list like this that is not here?
Very difficult to say, especially having seen the good work that is already being done. So nothing from my end. Great work.
No, I was
Yeah,
happy to
thanks,
see
Colin.
the
I really
agentic
appreciate
added.
that. Josh?
No, I was happy to see the agentic has been added to the pile, so I'm happy.
Yeah. No, it's where the world is going at the moment. It's the next frontier in AI and machine learning.
Yeah, and I think it's a good vision to also want to not just add it for the detection, but also help it with the explainability and the workflow that comes after. So I think it's quite exhaustive.
Thank you. Greg, I see you're off mute. Was there anything that you noted that you were hoping to see here that's missing?
No, you covered it all, really. I felt like saying SSTD to the agentic stuff, but I'll behave.
Yeah. It's robotic automation, but better.
Yeah, correct. Yeah,
Keyword better.
Okay.
yeah.
Alrighty. And then I think this is my final slide. So next steps, right? So in January, we are going to be creating a Tazama AI ML working group under the auspices of the Technical Steering Committee. We have had working groups in the past, and the governance structure for a working group is clearly defined in our charter and also published. So we'll be running this working group exactly according to the same principles as we have run working groups in the past. This will be led by the Tazama project product team. So that will be predominantly Sandy and myself. So we will be overseeing and guiding the operations of that working group and closely working together with the community. So what we are also calling for here is volunteers. If anybody would like to volunteer to contribute to this, please do send me a Slack message or an email of some kind so that we can put you on the roster. I know that not everybody in our community is in this meeting, but Ben, we are putting this onto YouTube as well. And I think it would be great if we actually put this out there so that people can review it and then hopefully also get as far as the call to action. So we definitely want community participation for this. In our next session in January, we will go through our key result areas and the improvement or the changes that we are making in our governance, in particular in how we want to move to a community-led project. And this will be one step in that direction as well, where as a community, we are going to come up with the requirements for AI in the product. And then we are also going to outline the solution and scope for the implementation of those AI features. And then we'll create and document that and then post it to the community. So ultimately, Tazama will not have its own capability to deliver on these, but we do see that we need to, as a community, collectively come up with what is best for Tazama, and we'll need to do that together. So please, if you have appetite or time or capacity or knowledgeable team members who would like to volunteer to contribute to this effort, please let us know, and you can contact me via Slack or on email. I should probably have put those in here because I did not. We'll add that to
We need to
this
make
after
a
the
list
fact.
of
But
guidelines as well, like explainability, the fact that it needs to be easily done in a UI, um, the fact that it needs to be just easy to implement as well, and that there needs to be an API for it, but it needs to be something that can be simple and automated as well.
so, Greg, I certainly hope that you are also going to volunteer to participate because that is incredibly good feedback and also something that we need to resolve in probably our very first working group session is what are the parameters? And I think you are correct. We absolutely have to have some AI design principles, some things that we want to offer as guidelines so that even if people do want to implement AI on their own, this is Tazama's perspective on what we consider to be best practice, best for the product, best for regulations, best for governance, and so on. So I think that's a very good call out.
Yeah. And of course, I'll be there, but again, I'll try to be in the background.
Oh, no, no. I think we're going to need you out front on this one.
Fair enough. All right.
Okay, and that is everything that I had on my agenda for today. Please, if you would like to volunteer and help us contribute and build the next iteration and generation of AI and machine learning into Tazama, please send me an email or send me a Slack and I'll add you to the roster. And I think that then concludes our session for today. Once again, just thank you to everybody who have participated in this session over the past year, and also the teams who have been working tirelessly behind the scenes to keep on improving Tazama. We appreciate your efforts, your involvement, your passion for the product. Happy holidays, and we hope to see you again next year.
Thanks,
Hey,
Justin.
Justice, actually, I have one more question. Is that the first time you've ever explained how rules work? I mean, you
No.
talk about it a lot, but
Yeah.
it feels like it to me. Yeah, rules are fairly
Um,
complex, but we try to make them simple. And if you will,
well, thank you.
the algorithm is called REDE, REDE. But it's really just it's a brainchild. So
No, thank you very much. I appreciate you saying that because I am working hard to get better at making it easier to understand. I mean, it has been it's been a complicated topic and it's been difficult to relay. And I'm very, very happy with that feedback. Thank you.
yeah, you're welcome. Thank you.
All right. Thank you very much, everybody. Happy holidays, and we'll see you again in January.
Thank you,
Thank you very
everyone.
much.
Thanks,
Bye-bye.
everyone.
Thanks, Justice.
Thank you.